Hello, hello, Isabella. Hello, Bill. Good afternoon.
Hello.
You're fast. It's fast. Good afternoon, Melissa. Good afternoon, Rick. Hello, Amanda. Hello, Ardell. Hello, Viola. Hello. Oh, thank you, Amanda. Hello, Brian. I know this is all cheesy, and I'm going to keep doing it because it's working for me. Hello, Brian. Hello, Rachel. I said that. Sorry. And this is also the secret place where we find out how badly I'm your names and you tell me privately. But okay, more people coming. Hello, but it's good to see you guys. Hello, hello. Okay. Um, more people are coming. Okay. Um, I have a full week of physics this week, which is like almost exciting to me. Okay, everybody's hello, iPhone. Wait, I even know. I know. Oh, hello. Oh my God, you guys are fast. That is just like okay, but yeah, party. Who's that? Someone else? Okay, sorry. Maybe not. And I even think, wait, here's where I get an extra point for class participation. I'm literally going to give myself an extra point if I get this right. I want to say that the person, the iPhone, like the person whose name is iPhone, I think that's Arleni. Am I right? Is that Arleni who's like iPhone? Yes. Okay. Come on. How cool is it? Okay. So hi, good to see you. Okay. Okay. And that's fine, by the way. I'm just being weird. Just trying to prove to myself that I know what's going on. Okay. And there's more people going. 100 points. Yes. All right. That's like the highest score I've gotten in a long time. Um, and certainly including any exam ever given by my children. Okay. Hello. But thank you. I totally appreciate the 100 points. Okay. Who else do we have? So we have Viola. We have Kaylee. Hello. Okay. I think this is everybody. Miles, hello, hello. Okay. Oh, in this chat. All right. And we're gonna and hello, yes. Oh, and hi, yes, hi. Hi. Okay. So things are going to keep moving along. Like hopefully each class there's like less of me talking about talking and more just like getting straight to physics, hopefully. And hopefully ideally like even the physics is more you than me, but whatever. What I can say, I'm really pleased with one thing. I put a little note in the stream like a day ago. I just want to make it clear, this is the nature of not being human beings and doing everything with like typing and emoticons and everything. Like I'm sure that what I put in the stream sounded passive aggressive or sarcastic or something. And I really didn't mean it that way. When I wrote in the stream, and maybe some of you may have seen, when I said like it's about time now to get going on the math methods homework, I really meant it like that. Like here, the reality is some people have given me the math methods and I all of it and I graded it and it's great and they rock and they got and they know a lot and they're good to go and they're gonna have a little break for a little while. Like we're not gonna have any new homework assigned for a little while. But then some people haven't done it, but that's because I kept sending a ton of mixed signals as to whether it was due or not. And also, like we're only just about to get up to it right now, the math methods. So it really is true that if you hadn't done it up until now, there's no harm, no foul, and no reason that you're blamed or anything like that. But it is also true that it's about time now to get into it, to get into homework number 2. I'm saying to get into it on your part. If you haven't looked at it yet, please start doing so today. But you're quite right. If you've thought to yourself, well, man, he hasn't even finished going over like homework 1 yet. Totally true. Which is why it's all good and all fine. And every single thing I've asked you guys to do so far as I could tell you really have done and you've gotten back, which I think everybody's like rolling along well. Today we're going to keep going with and just in a minute, there's no questions or whatever. In about 1 minute, we're going to get back to exactly where we were last Wednesday, which is all about question 9 on homework 1. Like it is true, just to be as clear as possible, whether good or bad, we are still on the last question of the first homework assignment. If you care, like that happens every single semester. It's like, it's not, it may feel weird or annoying, but it's just the case. It does mean again that you're not behind. If you're with me talking about the last question of problem 1 of homework 1, that is where we are. That's where we're going to return in a minute. But also just to make things as clear as possible, that question 9 gets into some seriously mathy issues that we do need to wrestle with in this class. Part of this class is dealing with calculus. And I get really defensive about this. I think this is a long time with it at the beginning in a way. Oh, wait, someone's here. Sorry, Billy's here. What I'm trying to say is and I'm going to keep saying this any different way I can, because I think this is like the psychological aspect of things that can make or break people. Like, in my heart of hearts, I love calculus. And in my heart of hearts, like, calculus and physics are very intimately related. There's no question. I mean, calculus is the language of physics, if you like, or, something like that. But they're chicken egg. I don't know which one comes. They really are chicken egg. Like, they're invented by the same people at the same time to do the same things. Like, I mean, physics and calculus, or they're discovered by the same people, right? So what I really want to emphasize to everybody is we're going to be deep in a little calculus land here for a while, maybe for the rest of the course. In some ways, we're going to go slow, or at least very carefully, with calculus ideas. And that can be good for some people and annoying to others. But why I'm saying all of it is to emphasize, like, in this part that we're going to, and even video, that's great. In this part, Will Furman in anyway. In this part that we're about to go back going over, like if you're a normal, responsible student, and probably this means like more responsible than I was, you may be very frustrated that we're going to take a while on one section of one problem. I'm taking even longer to say that, but you just have to know it's not an accident. You have to know it's not an accident, and that the more we talk about calculus, as we will today, we're going to deal with the derivatives and stuff like that, and we're going to be looking at them from the perspective of that math methods homework sheet. It's like meant to reinforce the same thing. We're going to be talking about calculus and derivatives and stuff like that. I just want to remind everybody, as we go down those roads, that my secret belief, or it's not secret, but like my objective when we do these calculus things is so that we can actually do physics right and not be BSy about it. But B, my true secret objective is to get everybody to learn calculus, at least to the extent that I want you to know it. I want to remind you each time we're about to go into calculus, what we're doing are things that I think I'm trying to explain to you right now. I don't actually really assume or expect or believe that everybody has this. I mean, I do expect everybody's seen things so that, like, words that I'm talking about and stuff, but but if there's any chance that any of you is going to like tune out once it starts getting more calculus-y because you think I'm talking about stuff that you're supposed to know, but you kind of know that you don't, please know, no, I'm talking to you because I don't necessarily really assume that people really are comfortable. That's the best way to put it. I don't care whether you know it or not. I don't really believe that people are comfortable with calculus. So this is an attempt to get us to get more comfortable with it through the physics. It's not to assume a prior level of comfort, even though you had prerequisites. That said, all of that said, what we're going back to, and I will pause for a second, see if there's questions, but what we're going back to then, when I say we're going back to the last question of homework 1, I mean, we are, but you have to know that actually, even in the context of that last question, we're taking this side road and breaking down the problem into smaller exercises that were not put in the homework sheet that we're discussing together as a group. Like, just to remind, that's the context, is we're doing some side mathematics to like beef ourselves up to be able to answer the mathematics involved in question 9. Like, again, that's just for perspective. Hold on. So where are we? So, sorry. So where we are is sorry, bear with me a second. Right. So we're here, like, we're back to this whole harmonic oscillation thing. I'm going to pause in a second, but just to end specifically to remind you, right, like where we were. Okay, so I'm babbling a little bit, just to remind you, like this page that you're hopefully seeing right now. This is where we left off, right? This is our physics context. That equation in blue in the middle is physics brought us to realize, oh crap, that equation is true. And we need to solve it. Like, we need to find X as a function of T. This is what happened to Newton and Hooke in the late 17th and early 18th century. Like, I don't mean to overemphasize this point, but please remember, the physics emerges, we discover the physics, and then we got to do math to figure it out. Like, a lot of times what's happened in history is we make up the math, or like that's what prompts the discovery of the mathematical technique. It's not like Newton or Hooke had a book that they could look into to figure this out. And I'm saying that, I mean, of course they're geniuses, and I'm not, and some of you are perhaps, but like, I'm not a genius, they're geniuses. So I'm not trying to say that just because they could do it, we could do it. But I am trying to say that math comes from human beings figuring things out. It, like, there's some, like, it has to be figure outable. It can't only be understandable after the fact. Otherwise, then it would have to be invented by robots or space aliens or something. So the physics brings us to this equation, d2x over dt squared equals negative quantity k over mx. The physics says that is the relationship between x and t. But what it really says is that's the relationship, that's the derivative of x with respect to t. And apparently it's some function of x. What we just want, we don't want freaking derivatives, we just want x, right? So we back to figure out what to do with this. We backed up. I'm just reminding you again, I will shut up someday. We backed up and said, let's look at kind of simpler versions of this, like this thing. Let's look at equations where there's derivatives in them and see what we do. So what we did on Wednesday, just again, quick reminder, and then we're almost up to where we are now, so to speak. On Wednesday, we did this, what's on the page right now. Like, and again, I think we finished it. Yeah, I'm acting on the assumption that we got this far. I gave you this problem. I said, okay, assume, like, again, and please see how it's like a doubly simplified version of the actual physics. And again, please understand, this is a sidebar math problem that we're doing to work out how to do the math. This thing says, imagine just arbitrarily that you have some function x of t. You don't know what the function is, you're looking for it, but what you do know is that the derivative of x with respect to t equals 5t, right? Like that's what I gave you last time. And then I gave you one other piece of information so that you could fully solve. And what everybody did and did correctly, well, ultimately, is we got an answer. We got the answer is x equals 5t squared over 2 plus 7. Now that's what we did Wednesday, and we will review that if we need to, like how we did it. But for the moment, I'm going to say that's what we did. And we did certain steps that I'm going to highly encourage you to like keep from your notes from them. And I'm going to highly encourage you to refer to when you try this next problem now. Like, and I really will pause to see if there's questions, but just to lay this out, this is what we did Wednesday. What we're doing, and I warned us, or where the purpose of it was to contrast. Like we got that, but excuse me, now what we're going to do right now, and this is where I'll pause, like this is what you're going to do, but I'll make sure there's questions or whatever first. And the questions could be on anything, on homework, on grades, like, but just so you know where we are, this next page, this page is where we are now. Like, this is what I'm going to ask, like everybody to try to do by themselves or with discussion or whatever right now. It's the same exact problem as last time. It is the same exact problem, except this crucial difference, which seems tiny, but it's crucial, is we secretly replaced the decaf coffee with Folger. No, we secretly replaced like the T that was in the right side of this equation in 5T, and we replaced it with an X. Please notice that only matters, like in some ways, who cares? Any of these letters, we could call whatever letters, anything we want. Like anything we're calling X, we could have called T, so who cares? But the who cares thing is that the left side, it still says dx on the top and dt on the bottom. So X and T, according to the left side, we're still dealing with a situation here where to be, okay, let me start writing now. Sorry, excuse me. We're still dealing with a situation where excuse me. Let me make this super clear. Like if I just walk up to you on the street and I just say like dx dt equals 5x, what is x as a function of t? I mean, first of all, if I walk up to you in the street and say that, you have every reason to be like, dude, like go back to your apartment and take a break. Like you should not be on the street asking people that. But okay, I mean, have you been to my neighborhood? Okay. But what I'm really saying is if I just literally out of nowhere say dx dt equals 5x, if I give you no physics context, if I don't define any of those variables or like say what the purpose is, it's still a legitimate mathematical question. And the thing I want to stress is if I literally say to you dx dt, like as I am saying here, equals 5x, then just from the way I'm saying that, you know right away that x is being treated as a dependent variable here and t is independent. Like just because t is in the denominator, because dt is in the denominator, and x is in the numerator of that derivative, that literally means like that thing is a slope. All derivatives are slopes. All slopes are like rises over runs. Rises are always the dependent variable and runs are always the independent. Very important. So we know right here that t is still the independent variable, yet this function is saying that, I mean, this expression is saying that our derivative depends on the dependent variable. That means I will shut up. It means that you're going to solve the same thing you did, do the same way you did Wednesday to solve this set of facts. But I'm telling you in advance that the mere fact that the t changed to an x, it won't change your procedure. It shouldn't change your procedure, but it will very much change your answer, like the nature of your answer. Technically speaking, now, if you do this when I shut up, which I will, I don't know what my problem is. Yes, I do. Ask my parents. When I shut up, you're going to try to solve this again the exact same way you solved Wednesday's thing. Just know that this mere technical change that we've just made from t to x makes this thing a proper differential equation. Like this, even again, don't be intimidated by that, but just know that this makes a difference, that we're changing from t to x. It actually changes the character of the relationship and of the answer, and brings it closer to what we really need to understand with springs, with harmonic oscillation. So this thing is a differential equation. Technically, it's first order. This exercise is technically first order because the derivative involved is a first derivative. So it's still not quite even as hard, if I may, as the thing we need to do in the homework, but it's a step closer. So I'm totally going to shut up and I'm going to say, this is a do now, please. Please, you're solving for x as a function of t. You want to get some expression for x, like we did last time. We got like 5t squared over 2 plus 7, blah, blah. You want to get an expression for x that only has t's in it. Anything else should be numbers. Like there will be a c in your answer for a little while, but then you have to solve for that c, get rid of it, and get a number for it. So that's what we're all trying to do right now. And I would say, oh, there's already stuff in the chat. That's great. But even before I look in the chat, I'm just going to say, I definitely want any thoughts, any questions, anything. I definitely want people to like participate with this. But right, if you think you have a final answer, maybe private chat is the better way to go. That's your judgment call. But I'm gonna shut up now. But that's what we're doing now. We're trying to solve this problem. And I'm gonna look in the chat to see what we're saying. Oh, cool. Oh, wow. Okay. And so I'm definitely getting some impressive things. Or not to, I don't want to rush anybody. This does. I'm going to be quiet for a while if I can, or at least I'm going to let you work for. But yeah, I'm already getting some definitely impressive things in the chat. Again, I would say if you have a final answer, yeah, maybe being private chat makes sense about it or something. But all of you feel free to give any input or whatever. But please, but especially if you don't understand what the question is, please let me know, because otherwise I'm going to assume that everybody's working on this question right now, which the one on the board. I'll even try to put it in the chat to make it more clear. Ah, okay, I'm beginning to get just, I was about to type something to the whole group, but I'm beginning to get some things in the private chat. So I just want to acknowledge things are happening in the private chat, which is cool. No, I think that this time is, I was about to, so I'm seeing the things in the private chat. I'm going to respond in a second to those of you, but everybody keep going. This is good because I can see that people are making progress. And it is more than one person. I mean, I can see that people are doing things in the private chat, but I can also see that so far it seems like no one is actually there at the end, which is fine. So, well, so I'll write what I was about to write. Oh. Yes. Sorry. One second. Um, Bear with me for 1 second. Sorry. Yes. Yes. Sure. Just okay. And again, to all of you, I'm just trying to catch up with there's a lot in the chat, which is great. So if you already put something in chat and I haven't responded yet, it's just because I'm getting to it, so I apologize. But to all of you, by the way, like the best thing you can do in these moments is to try. I mean, the hardest thing to do in these problems is to write anything down. Like the hardest thing is to know how to start or to do anything. I know that, believe me, I know that. But that's why the secret to all these kind of problems is to write something down, like for real. Thank you so much. Thank you. Thank you. Like really what holds us up is the fear of writing down something that's wrong. But if you really think that through, if you're really willing, like, and maybe for some of us, you might even want to have a notebook that's just for wrong crap. Like if you're very together person, which I'm not even a together person, and yet I still suffer from this kind of perfectionism, whatever that we all do. But like I've seen some people like who are not only perfectionists, but they generally actually are successful at being perfectionists. Like everything does look perfect with them. Astounding. But that can hold you back in a problem like this. What I'm saying to everybody is be willing to write some crap down just to get some crap so that you can look at it and start fixing it to make it right. And if you don't want to deface your beautiful notebook with your beautiful correct stuff in it, like it might be worth just having a separate notebook or pad for the crap that you work out, like a scratch pad. But for everybody, what I really say, so I still have to catch up with a couple of chats. There are a couple of people who put something in the chat, haven't heard anything from me. I apologize. But if you're really, really, really stuck, the very first thing you should write down really is a given, like the first given. And what you want to do is manipulate that given so that you can start getting yourself somewhere. You want to separate the x's and the t's is really the first thing you want to do in that first given. Would be my first advice. And look back to what we did Wednesday for that. But anyway, all right, I'm going to shut up. It's getting a little more time. I mean, I guess I'll say this one thing. Oh yeah. Well, what's on the page here is just a reminder of what answer we got from the first one. That I don't know if that's so helpful, but wait, sorry, I'll go back. Okay, no, I'll just do. Well, actually, what I'm going to stall a little bit more for. Well, I'm going to on the next page. I'm going to open up a new page now. I'm going to start writing. I'm just going to remind you what we did on the other one as quickly as I can without over talking it. But I am asking, like, if you're anybody who's stuck, and again, I see in the chat that many people are doing something very right at the beginning. They're doing the hard part right at the beginning, but then getting stuck somewhere. So that's fair. I can't address that just yet, but as far as how to start, let me remind you all of how we started last time. The key thing that we did last time that we've got to do this time, like, no, let me, I'll pause for a second. I mean, and then we went on from here, but this sheet, what I just wrote down, the first couple of steps, it's the key because the lesson here, I mean, I haven't said the lesson. I mean, we're about to do this together, but I want you to see from the last example, it's just like question 4 in the homework or something else where like, I'm giving you guys the derivative and I'm asking you what the function is. So what a lot of you are very intelligently and very reasonably and like admirably doing in your brains, I mean, I think, is I say, here's the derivative, what's the function? So what a lot of you are saying is, okay, if he gave me the function and he wanted the derivative, I would like differentiate, I would take a derivative. But that's not what he's saying. He's giving me the derivative and he doesn't want me to differentiate again. He doesn't want the second derivative. He just wants the original function, he meaning Yaverbaum. So what a lot of you are saying is, oh, he's giving a derivative and he wants me to work backwards. Therefore, he wants me to like anti-differentiate. So therefore, that's where integrals come in. And you are right to have learned that. Like any one of you who is thinking derivative backwards means integral, you are right. I mean, well, it's a very good thing to think anyway. But that shows that we want an integral. It doesn't show us how to get the right integral that we want or how to set it up or how to justify it. Like we can't just make up an integral because we think that that would be helpful. So what we do to get the integral that you were looking for, what we did last time, so I guess I'm now explaining things, like I gave you dx dt equals 5t. So what I suggested last time, don't just integrate. You could just integrate and sort of by dumb luck get the right answer. But I'm saying that's dumb luck and it's not always going to work. Don't just integrate. Multiply both sides by dt. This is the key step that seems unnecessary or maybe even seems illegal. But the key step that we did last time was we multiplied both sides by dt. So we separated the independent variable from the dependent variable. And then we saw that on both sides of the expression, on both sides of the equality, we have expressions that can be integrated. Because to integrate means to add up, right? An integral is a sum. Why is it special? Why is it such a big freaking deal? Because it's a continuous sum. Like an integral is just a sum. In fact, that's why it's that symbol. It's supposed to look like a big scripty smooth S. And it's a substitute for that old clunky symbol that you used to use with a big sigma, the big capital sigma that also stands for sum. We stopped using those sigmas and started using integral symbols because the only difference between a regular everyday sum and an integral is a continuous sum. In an integral, you're adding up a bunch of non-countable pieces. You're adding up a bunch of pieces of something that each piece of which is so small. How small is it? It's so small that it's like infinitely small, like for real. An integral means you're just adding up a bunch of little things, but each one is so small that it's not separable from the next thing. Oh, here we go. 1 second. Yes, sir.
Are you gonna give me a Mewtwo soon?
Wait, that's the other class that's coming next. But yes, let me ask them too. I'll ask it, but because today's a long day. So if anybody in this class plays Pokemon Let's Go and has a Mewtwo that they're willing to trade with this guy
for a Moltres.
For a Moltres. What level Moltres?
I think like he's in the 50s.
Oh wow, that's pretty good. Can you go any higher? Can you give him like anything, even like a level 16?
Well,
anything?
He has one of the strongest fire attacks.
Oh, that okay. So
Heat Wave.
Oh wow, that's cool. So a Moltres with attack Heat Wave. So if any of them has a Mewtwo, they'll let me know, and we'll see if we can do a trade. Okay, and this isn't even that class that they might. I don't even know about that. It's the other, but I'll tell.
Bye.
Okay, bye. Nice to see you.
See you later, guys. Hopefully you had fun meeting me.
I'm sure.
Tell them my name and my age and how.
Wait, but if they can't see you, then they can't see. I mean, if you can't see yourself, now they can see. Wait, go closer so they can see you. Okay, yes. Tell them what? What should I tell them? Your age?
My name.
Hi.
Hi.
Oh wow, look at that.
How are you?
Do you have a Mewtwo?
I think so. I don't know if Yaverbaum's gonna upload this to YouTube. Oh, there goes.
Oh whoa, that was almost like
yeah, my cat decided to make a surprise appearance as well.
Whoa. All right. Well, all right. So we'll ask. So if she does, we'll see. We'll look into it. If they do, we'll see what we can do. But thank you so much for meeting them. Or they thank you for meeting you. But now we're disappearing. Okay.
Bye.
Bye.
Good job. Okay. Sorry. Okay. Thank you. Sorry. Okay. That was okay. Thank you for indulging that. Okay. And that was okay. Sorry. Thank you, Cynthia, and anybody else who just put up with that. Thank you.
Now back to our regularly scheduled programming.
Yeah, right. Exactly. Who knows which is, yes, exactly.
No, don't stress it. It happens.
Oh yes, it certainly does. Yes, and okay, anyway, yes. Oh, but the offer is I can't give extra credit for a mute. Well, anyway, all right, okay, I'm gonna go back to this. Yes, but he is serious, as you can imagine. All right, so what am I saying here? I'm saying, I literally don't even remember them. Oh, I'm saying that what we had to do in order to set up the integral last time is we had to separate the X's and the T's and put them together. And the truth is, it makes total sense that we would do that. What may be new to many of us, you might not have known we were allowed to do that. You might not know that you're allowed to take a derivative and split it up like that and treat it like a regular fraction. But and in very rare cases, you're not. But this is not one of those cases. And for me, it's very useful to always remember that derivatives are ratios. Derivatives are slopes. It's just that what's on the top and what's on the bottom is infinitely small. Oh, and that's what I was saying about the integral. So the integral is just adding up a bunch of infinitely small things. But you have to have the little things to add up. That's why an integral means, like, to see an integral and solve it, you need to see that S, and then you need to do a D something, because what you're actually doing is adding up a bunch of things, and you need to have things to add up. And that's what the D blah terms are. Okay, so this final expression that we got on Wednesday, both sides of it can be integrated. And we did. That's how we got an answer Wednesday. What I'm saying here now is you got to do the same thing here. Oops, only it's with a different expression now. Right, like now it's an X, so that's going to make all the difference in the world in terms of our answer, but it shouldn't. Oh, sorry. Oh, sorry. Sorry, 1 second. Just responding to. What I'm saying here is we're going to do this. Sorry. I'm going to do the same thing as before. I'm going to multiply both sides by dt. So I have but it's still a mess the way I have it right there. I mean, it's better, but it's not quite there because now I have like x's and t's together on the right side. Like dt suggests that the variable of integration is t, but then I've got this variable x that's in there, so that's not good. So what can I do? I can do something like this. Now that, excuse me, that's legal. It's already looking a little bit more intimidating and a little bit more messy than our other example, maybe, but it's got the same doable form, which is all the x's together, all the t's together, and specifically each side containing a d blah term. So each side is now integrable. So I'm doing it now, but this is what I'm just closing it. But like now I'm going to integrate. Just note that in both cases, sure, we're going to integrate because we're trying to do a derivative backwards. But to know exactly what to integrate, we have to do something first. Hold on. Okay. Now here's the thing. Here's right what I'm about to do now is where I know that at least 5 people in the private chat were doing something very right because they got at least, maybe not 5, like 3 or 4 people in the private chat had an answer that even though I said was not quite right or not quite finished or something, it had a piece in it that was very important that we're about to see here. Like, well, so the right side I'm saying is this. Wait, I should have asked you guys, but do you agree? Can I just, that's the right side. Is that fair? I mean, I'm saying the integral of 5 dt is 5t, but plus c because it's an indefinite integral. That's the right side. Like, stop me if that's not okay. But the left side, I would ask, but I've seen in the private chat what some of you definitely know or remember is the integral of 1 over, well, I mean, what we have here on the left side really is right. That's what the left side is. And the answer to that you like know from math, or I guess, and this is an example where I guess you do have to know something from a math class. Like, that is a knowing thing. I mean, I can explain it, but it's a whole, I mean, it's not obvious, right? There's no way you could just figure out that the integral of 1 over x dx is natural log of x. I mean, one can figure it out, but no, I wouldn't expect anybody just in 3 minutes to figure that out. But that is true, and I think familiar to at least some of you, right? In other words, I'm saying, oh, excuse me. Right, that gets a plus c also. So to be totally fair, so to finish this step, I'm saying to be totally fair, something like this. Like, this is what I think we have so far. And I do want to pause. Is that fair so far to people, what we have so far? Or does that make?
Yeah, it makes sense to me.
Good. All right, cool. Good. Thank you. That's a resounding good. Okay, cool. So we've got that. And thank you. I also see in the chat. Thank you, Amanda, also. And thank you, Isabella. Okay, so then I'm going to write on the next. Sorry. So just recopying for a second. We have this. And it doesn't matter which one I call C2 or C1 or whatever, but okay, so this is what we have so far. Now, like, we're getting somewhere, right? We have, oh, let me just see the chat. We have x by itself, we have t. Cool, okay. We have x by itself, we have t by itself. That on the other side, that's good. We're getting somewhere, but first of all, we've got all these c's flying around. Ultimately, we need to have no c in our answer. we don't want any unknown constants in our answer. We certainly don't want 2. So the first little trick we do that I'm going to drag out, I always do it. Oops, sorry. Oh, question or? Okay. Now, I'm not saying you literally have to write out these 2 things every time once you get used to this idea, but this idea does come up a lot in physics. This is how I'm going to like reduce the number of constants I have. I'm ultimately saying this. Like I tried to do this last time. I just want to repeat those 2 lines, let C3 equal blah and let C equal, oh, sorry, that's right. Is my way of saying, C2 and C1, we could put together as one constant, just call it C, like C, we could subtract C2 from both sides and call that one number, like a number minus another number is a number, right? And then if that's the only number, if C3 is the only constant in our situation, there's no reason to call it C3. We can just call it C. So it's just like a clever little renaming thing so that we now can write our expression out as only having one constant in it. Now we're still going to have to solve for that constant. I still have to solve for C, as I was talking to some people in the chat about. But I'm going to hold off on that for one step because right before we get to solving for C, we're almost there. We're not quite, we want an expression for X, right? We want, sorry. We want X by itself as a function of T. So we don't want the log of X, we want X. So we want to undo that log that's on the left side. We want to undo it. We want to invert it. We want to do the backwards version of it. Like, it's just like the same thing as if we had, if we had that 2x equals 5t plus c or something. If we had x multiplied by 2 equals blah, blah, we want to get rid of the 2 by doing the inverse function of multiplication. We'd want to divide both sides by 2, right? So that's what we want to do here. But we don't want to, oh, sorry. Right? I mean, oh, yes. Okay, exactly. That's what I'm trying to say. Yes, yes. If we want to invert logarithm, we want to do the inverse function of logarithm, which is e. That is 100% correct and 100% the point. And that's 50 points for class. Actually, that's 75 points for class, right? Because that's like a for right or wrong class participation thing. So yes, I want to do e. I'm going to raise e to both sides of the equation. Sorry. Right. I mean, that's the short version or the long version of what Isabella just said, that like e to the ln of something is the thing itself. So that's why I do agree. I want to raise both sides of the equation we have to e. Yeah. I want to raise e to the power of both sides of what we had. Thus. Right, this is what we have so far then. And I'm, well, as usual, I'm, inserting steps, I'm dragging it out maybe, but hopefully making it clear. The left side then, actually it's not clear because of handwriting. The left side then, the reason I'm doing what Isabella said is because then the left side becomes what I want, X. And on the right side, we're almost there. Now we have this. Right. Yeah, this is weird. Like all of a sudden exponential functions are like all of a sudden just because Isabella said it, like there's an E in our life. Well, of course, it's not just because she said it, it's because she was right. But it is noteworthy that we started with something that just had not like dx dt equals 5x, like kind of simple looking, and all of a sudden there's exponentials here, like, and there weren't exponentials on Wednesday. So it's something to notice, something that happens when differential equations arise. Their solutions are often interesting functions, or at least not simple functions. We have this, we're still not done. We're almost done, but we're not done because we still need to know right? We still have to do the same thing we did on Wednesday, which is solve for C. But, okay. Oh yeah, and so I got a couple of comments in the chat. Like, I think the first hardest thing about this problem is basically even being comfortable with dividing both sides by, multiplying both sides by dt, and even realizing that if you set up the integrals properly, you're going to get a logarithm. And people in the chat realize that. But then some people in the chat very legitimately like pointed out they don't remember log rules. Fair enough. I don't expect, that's fair. I don't expect you to have them all at your fingertips. But I am going to have to use them here a little bit. So I'll try to remind you of them. Like, the first thing I want to say is I've got this x equals e to the 5t plus c. And by the way, I love e, and we're going to talk about e, e the number, and we're going to talk about that and stuff. But don't be intimidated by it yet, even if it's cool and interesting. It's just a number, e. It happens to be 2.7, blah, 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 but it might as well just be 2 or 2.7. Like, the important thing is that we're taking a number and raising it to a power here. So let's remember how that works. Like, I'm saying, actually, oh yeah, here, yeah. So I'm saying, here we are, top line is x equals e to the power 5t plus c. Well, I'm claiming first and foremost, and again, this is just something you get used to in physics. Like, none of this stuff none of this stuff mattered to me in math when I just learned it abstractly, but then once I started using it, it started mattering. So I'm saying x equals e to the blah power, to this complicated power, is the same thing as e to 1 power times e to another power. Once you see it, you might remember that that's true. I'm just trying to refresh you. It really is just because, it's because powers, exponents, are just shorthands for repeated multiplication, right? Like, 2 to the 3rd power means 2 times 2 times 2. It means 3 2s all multiplied by each other. But just like multiplication itself is repeated addition, right? Like, 2 to the 3rd power means 2 times 2 times 2. 3 2s joined by multiplication symbols. 2 times 3 means 3 2s joined by addition symbols, right? 2 times 3 is 2 plus 2 plus 2. 2 to the power 3 means 2 times 2 times 2. If you think about it that way, it kind of does make sense that adding exponents means multiplying numbers. Just if you just look at this, I'm just trying to refresh you on why this makes sense, at least to me, that 2 to the 4th times 2 to the 3, 2 to the 2nd times 2 to the 3rd equals the same thing as 2 to the 2 plus 3. That's the best way I could say it for now. Again, we could talk more about it if anybody has questions, but I'm saying that is the way exponents work. Therefore, excuse me. Therefore, I can rewrite this expression up here on the top as x equals e to the 5t times e to the c. Now, why do I care? Well, because now, if you look at it, okay, x equals 5, and we're almost done, x equals e to the 5t times e to the c. Well, multiplication is commutative, so I could just switch that around and just put the e to the c first. Okay, that's just a style thing. It doesn't really change anything, but now I'm saying x equals e to the c times e to the 5t. But now I'm going to do my trick again with constants. Like, we play this game all the time we always end up with these constants in physics and in math, and we want to solve for them. So we think it through logically. We say, oh, wait a minute, C is just some number. I don't know what it is, but it's just some number that doesn't change. Now, E is also just some number. I happen to know what it is, but it doesn't matter. E, some number raised to the power of C, some other number, is just itself some number. Now, by the way, it might not be a rational number. Like you might be aware that E is not a rational number. It's actually even crazier than that. It's called a transcendental number. It's like a very interesting number. It certainly is not like evenly divisible by like anything. But who cares? We never said that our arbitrary constant C was necessarily a rational number or a even number or anything like that. Sorry. So I'm saying E raised to the C, that's just shorthand for some number that I could just call C2 or C3 or just C itself, right? Just like we did before, we combined C1 and C2 and just called it C. And it seems like we're breaking the rules of math. We're actually using the rules of math to get out of boring math, like to get on to what's interesting in math to us. So I am saying here, a long way of saying, okay, right now we have an expression x equals e to the c times e to the 5t. And this is like a hard part. Like I wouldn't expect it. So a lot of people got logs in their answer, but sort of didn't know what to do there. Fair enough. Like I'm showing you. I'm now saying x equals, I'm saying this right now. I'm saying if I really believe that e to the c is just some number that I might as well call c, then what we have so far is x equals c. I mean, we've really simplified this thing. X equals c times e to the 5t. Now I can solve for c the exact same way I did in the earlier problem. I can literally use, and I'm actually going to pause for everybody to do that. Like you might not have done everything I just did. I might have shown you something. I don't know. Like, I mean, I hope, I guess, but even if you didn't do that now, maybe if it's clear, try the last bit. Like given that x equals c times e to the 5t, use the fact that when t is 0, like our other initial fact that we haven't used yet is that when t is 0, x supposedly is 7. That should be enough. Like plug in that information and we should be able to get what c is. And I'm going to pause again in this class. Okay, yeah, I'm going to pause again to let you do that. I'm going to walk away for a second. So, I mean, does anybody want to take a shot at, I guess what I'm asking right now, the final step I'm asking anybody is what's C equal to based on this? Yes. Awesome. Yes, totally. That's good. And very good. And the reason, and that's 75 points. And I'm psyched. That is true. What's in the chat, what Isabella said. And a key, yeah, totally true. Therefore, the answer will be x equals 7 e to the 5t. Well, okay, here. So this is to show what Isabella just said. I'm sorry, I'm having a little like a physical mechanics issue here that may cause us to abbreviate class slightly. But this screen right here is, so I'm here doing what Isabella just said. And this is always, so this is basically what I'm showing you guys. Yeah, I agree that C equals 7. And all I'm doing to get that C equals 7 is I'm plugging in 0 for T and 7 for X, because that was a piece of information that was given. That information that was given was an initial condition of the problem. It's what we need to fill in the arbitrary constant, the plus C. We need that information. If you think about it, where that plus C came from in the first, like why do we even have a plus C in the first place? Why does a C pop up where we don't know the number? Because we had an indefinite integral, right? And what does it mean to have an indefinite integral? It means an integral where you know something about the function, but you don't really know where you're integrating from or to. Like indefinite integral is a situation where you have some sort of description or rule or a function or or otherwise description, rule, pattern. But if that pattern, you just know the pattern and you don't know, oh, the pattern starts here and the pattern ends there. You just know the nature of the pattern. That's an indefinite integral. Like you don't know what you're integrating from or to, you just know you're integrating. So you can't get an actual numerical value. You can just get a concept. And then it has plus C at the end of that concept, saying that the actual numerical value depends on where you actually integrated from or to, right? So generally in a math class, if you have an indefinite integral, you get a plus C. If you have a definite integral, if you have the boundaries of integration, you don't get a plus C, right? Well, here we have the situation where we get a plus C, but we're able somehow to solve for it. Why? Because of this page, because the truth of the matter, like this procedure where at the end, after we're done with an indefinite integral, where I say, oh yeah, but let's look at that piece of information about what X was right at the beginning. Let's look at that piece of information of what X was when T equals 0. That's really a secret way of saying, let's look at where this integral began, or where the application of this integral began. In other words, when a physicist gives you an initial condition, this is what the screen is trying to say right here. I'm now going to put it in like slightly different words, but it's the same thing. When a physicist gives you an initial condition, like the very first position is 3, or the very first velocity is 0, or anything like that, when a physicist gives you an initial condition, in effect, they're giving you the limits of integration. When a physicist gives you an initial condition, they're in a different form, giving you the same information as you would get if you knew the limits of integration. That's what I'm trying to say here. The constant of mathematical integration is the same thing as the initial condition of physics. Maybe you'll see that more and more as we go. But by telling you that X of 0 is 7, I'm in effect saying integrate from 7 to something. That's like, so anyway, so I totally agree with Isabella. What we have then in summary so far, and I know we're going to wrap very soon. I know class ends in 9 minutes and something's happening with me that may end us earlier than 9 minutes, but what we have in sum so far, and we're still in this math land. We're still like inside question 9 of homework 1, and I'm aware of that. But what we have so far is this. Yeah. I'll pause for a second just so you can, like we have I've just given you 2 problems that are like the building blocks for question 9 on homework 1. I mean, 2 problems that contain the elemental pieces of question 9. These 2 problems are extremely similar, right? dx dt equals 5t is problem number 1. dx dt equals 5x is problem number 2. But I want you to notice, just look at both of these things. Again, this is where we're sort of going to wrap up for now, like even if it's kind of like a not total resolution of the homework. I want you to see that these 2 exercises, they're very similar. They both contain a derivative. Only the first exercise, I would say, is an equation that contains a derivative, whereas the second exercise is literally a differential equation. They're both first order. Both of these are just regular derivatives, not second derivatives or third derivatives or anything like that. But the first exercise is really an equation that has a derivative in it. And I say that because the independent variable is on both sides of that equation. But the second exercise was actually a true and proper differential equation, simply And entirely because that variable on the right side is x rather than t, I'm saying it makes all the difference in the world in terms of what we call this thing. And it makes all the difference in the world in the answer. Look, like both answers are complete answers. Like, and they have 5s in them, they have 7s, not coincidentally, and they don't have anything unknown. But the answer to the first problem is what is kind of a standard looking, what you might call algebraic or power function. Like it looks like a lot of regular physics and math. Like it looks like 1f(at) squared plus v naught t. I mean, it's something t squared. It's a parabola. We've seen it before. It has 2 roots. If you took 2 derivatives of it, you'd get down to 0. Like it's a very dealable kind of equation. The only kind of equation really that's easier than it is a linear equation. I mean, this one right here. But this second thing, like point number 1 that I'm trying to make is that the second exercise really is a differential equation, whereas the first one really isn't. And it's a differential equation because the variable on the right side is x, not t. Like for that stupid a reason, but it's not stupid. And notice, and I'll try to say again in English why we call that a differential equation. But if you just accept that rule for the moment, that second thing is a differential equation, and it's about as simple as they get. Like the one in the homework is not as simple as that. And simple doesn't mean easy, but like this differential equation right here, that, wow, I don't know what that sound is, but this differential equation right here, this, we happen to be able to solve it with the same method we solved the other one. But what we got was an exponential function. And if you're at all intimidated by exponential function, or if in any way you think exponential functions are slightly less familiar or slightly less easy to deal with than like 5t squared over 2, you're right. And you should think that. Like, don't run away from it, but do respect it. Like, this is a different kind of function for sure. And it's not a coincidence. Well, the takeaway for today, since we are going to end in a second, again, we're not going to finish problem 9 today, and I apologize for that. But a takeaway here is what's written right here. If you take a moment to. Sorry. And actually, I guess what's written on the board here, I just said in English. You could take a minute to write it down if you want, but I'm going to go one more board, and then we'll hold. Well, tell me if you want to go back. I think the main thing I want you to write down, or the main takeaway from this is, oh, wait, you don't have to worry about that for the moment. Hold on a second. Yeah, note this. I'm just trying right now to contrast our 2 answers. Answer to problem number 1 was like 5t squared over 2 plus 7. Answer number 2 was 7e to the 5t. Very different. What's one big difference? So this is the thing I'm writing that down. Again, this is like the end of today, but all finite power functions, like even really exotic ones, like even a function like x equals 17t to the 9th minus 14t to the 8th plus 21t to the 7th. Oh, and then to be clever, minus 0t to the 6th. So there's no t to the 6th, haha. But then minus 5t to the 5th, blah, 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 plus 7 equals 0. Like some long thing like that. That can be really long and intimidating, but as long as it's a bunch of powers, and as long as all those powers are finite, then if you take derivatives enough of that function, like if you take the derivative of it, you'll notice all the powers go down by 1. Like that's how you take derivatives, right? And then you take another derivative, they'll all go down by 1 again. You take enough derivatives and eventually you'll hit 0 for any power function, no matter how complicated, no matter how high the power is. You take enough derivatives, you eventually get to 0. But that is not true with e to the x, right? E to the x, the derivative of it. Oh, I guess we haven't even. Oh, yeah, sorry. The derivative of e to the x is e to the x. So it doesn't get any simpler when you take a derivative. That's a very different beast. I'm here to claim to you. Oh, sorry. I guess there is one more slide. I'm here to claim to you that as long as we have to deal with differential equations in physics, and we do, many people would argue that physics really is the study of differential equations in nature. We do. We, again, don't want to assume that you've had differential equations before. I'm not assuming that. And frankly, if you did have them before, I'm worried that they'd corrupt your view of my view. So we're not assuming you've had differential equations before, but we are assuming that we're going to deal with them in physics in this class. And so the first thing I want to tell everybody is that like what I mean by the solution to a differential equation, I mean x as a function of t, or like dependent variable as a function of independent variable. That the solution, like it's always a function. What we're always looking for in differential equations is a function. And the function we will get as an answer to a differential equation might sometimes be E, might sometimes not E. But the answer that we get to a proper differential equation, like the one in homework 1, like Hooke's law thing on a spring, whatever answer we get there, and we still haven't gotten one, and I know that, but whatever answer we get there is going to be a function, and it's not going to be a power function. It's going to be something where no matter how many times you differentiate it, you still get back to yourself. Otherwise, it won't satisfy that differential equation. I mean, I'll say that more on Wednesday. But I'm saying whenever you face a differential equation in physics and you try to get an answer, your answer will be x as some function of t, and the function you get better not be a simple power function or linear function, even though we'd all like that better. It won't be. It's always going to be something like e to the, or maybe like sine of x or cosine of x. Any of those functions where even when you take derivatives, you get back to the function itself, right? Like sine of x, what's the derivative? It's cosine x. What's the derivative of that? Negative sine of x. What's the derivative of that? Negative cosine of x. What's the derivative of that? Sine of x. Like eventually you get back to yourself. It's functions like that that will be our answer to a question such as the one in problem 9 of homework 1. But I've said too much. That's all I need to say today. Sorry to keep this going. I'm just going to say, I do have to rush off for another class, so I can't really answer real questions right now, but if you're good, but I will post everything obviously and continue with this on Wednesday. And there's not any new homework, just try your best with math methods. So that said, can I just see if I'm good, if I could just get some goodbyes or any, oh, thank you, Ardell.
Thank you, Professor.
Thanks so
Thank
much,
you. Thank
Professor.
you.
Have a good day.
Thank you guys very much. I totally appreciate it. I will post everything. Thank you. Oh, good. Oh, good. Okay. Awesome.
Thank you, Professor. See you
Oh.
Wednesday.
Thank you very much. See you Wednesday. Thank you guys. Seriously. I just saw some private chats. Great. I appreciate thank you. Awesome. Great. Thank you. Thank you. Awesome. Thank you. Awesome. Thank you. Great. And Amanda, you're good or for the moment or?